we are seeing all the core components, that first of all what is AI, then what are the core components for building a AI model, and different types of AI. So based on the components you're using there, especially based on the algorithms you're using, there'll be different types of AI systems, and we'll see their role in cybersecurity also. And then we'll kind of do a SWOT analysis of AI in cybersecurity, and then we'll see how you can use AI as security controls. And since we'll see the threats, also threats for the AI systems, we'll see how they can be safely developed and deployed. Okay. Then finally, we'll see that where we are using AI as a productive tool in cyber offense and cyber defense. It's just imitating, but it's not same as the human intelligence, at least at today's level, right? People are still talking about artificial general intelligence, AGI, this term, right? That will it come this year? Will it come next year? They were even saying that this GPT-5 which came out, it might be AGI, right? But when it came out, we saw it's nothing like not much improvement from GPT-4. There, like many people were disappointed with the GPT-5 that when it came out. Okay, so we are like scientists, the AI researchers who are there. Some of them they say that AGI will be here by 2027. This AGI, by the way, is those AI systems that are as capable as humans. They'll be as capable as humans at a wide variety of tasks, right? So right now, what we have the artificial narrow intelligence. Okay, on some tasks, okay, they are better than humans, but not overall as a whole, right? So our job is to leverage this ANI and also to make them secure. Yep. So I heard like all these things that came in your mind. Okay, we are replacing the, it is mimicking human intelligence. I saw better automation over here. Okay, so AI in itself, like the definitions, though I'm not a fan of definitions over here, but the person, John McCarthy, he is the person who coined the word artificial intelligence way back in 1956. Right. So even just imagine in history that, okay, even a thing such as a calculator when it comes up, right? That huge, that time, one room, huge devices like were there, those computing machines. They had the task even for this, what simple task we find today as calculation. So we don't find it amusing. Right. But at that time, they'll think, okay, there's a machine that is actually calculating faster than the humans over there. Right. So generally, like naturally, these things will intrigue them. Right? They will think that, okay, this is some intelligence, some form of intelligence that we have here. Okay. So you can say the science and engineering of making intelligent machines. But now the question is these intelligent machines, because with time, the definition of these intelligent machines also keeps on changing. Right. So currently, what we have here, as most of you mentioned over here, we have human-like processing in our AI systems. Right? So you can see that how this ChatGPT has the ability to understand our language using text to speech. We can transfer. So when it understands our language, it can even talk to us. You must have seen a lot of videos like this where people are conversing with ChatGPT, not just typing with it, right? And now we can even give it the images that we have, so it can process the images. So when you talk about robotics over there, so they are also say they are looking like humans, you're trying to make them look like humans. And just like how humans, we have the sense organs over there. So we have the ability to talk, we have the ability to listen, talk, and even see. So same thing with the sensors, you're creating the robots also, right? We have such kind of robots also where we have integrated your LLMs like OpenAI, ChatGPT with these robots, right? And they have the ability to talk, understand to us, and via sensors, they can even see the things, right? So this human-like processing we have in the artificial intelligence systems, and of course, since they are just like humans in the form, like they have the human-like processing, you can use them for the problem solving tasks, right? You can give them the complex situations and they will make the intelligent decisions for us. Right. So now it's up to us that how much we are dependent on them and for what all tasks we are using. Are we using them to assist ourselves or completely replace ourselves? Right. So we have to use these tools smartly also. Okay. And now the thing is, what gives them this ability over here, the ability for problem solving and this human like processing? What ability, where do they gain this ability from? So I would say it's their ability to recognize the patterns. These different things are in one way the form of data only, right? These are types of data. So you can have text data also, voice data, image data. So even like when we are using these LLMs like ChatGPT, they are even trained on the user data also. Right. That's why we say that we should never enter any sensitive things in these, right? Because they'll later be reflected like in the training data and then they can be taken out also from there. Okay. So this pattern recognition, they do it in the data. They're able to recognize the patterns. So if you say, okay, we are talking about AI in cybersecurity. So say if you want to build a model that will detect the network-based attacks. So what you can do, you can collect some data. So data collection is an important step that we have in model building, right? And over there, what you'll do, so say there are many tools to collect the data. You can collect it via through the Wireshark because from Wireshark you're doing the packet analysis, isn't it? Have you heard about Wireshark, all of you? Yes, right. So manually you can do it, okay, through Wireshark. Later on, like you can even automate this process by using its command line version, the T-Shark or PyShark in Python, because you know this for AI model building this we have our Python language which is quite easy to use over here. Yes, yes, it's a yes network. So you can see it's a packet capture tool that we have. Okay, it's a packet sniffing tool. So we can capture our real-time network data using Wireshark and automate it using tools like Python-based tools like Python-based libraries like PyShark that we have. Okay, so we can automate the data collection process that way and all the pre-processing, how you have your unstructured data initially via the pre-processing, you will convert it into proper rows and columns of your data. Okay, where there will be various fields over here like your, so I'll just give you a example of a data set, how a structured data set will look like. So that will give you an idea that how this pattern recognition is working in these systems. Okay, so this is a data set that we have collected just from Wireshark. So you must have seen there are things such as your packet number over here, your timestamps, your source IP address, destination IP address, the protocol used. Okay, the length of that packet, right, in bytes that we have, then source port, destination port, and other information, maybe some flags, maybe if TCP is used, so the TCP flags information, right? If HTTP is used, then the HTTP request and response methods being used over here. Okay, so this is all our data set. Now, from this data, okay, this one is your normal network traffic. Okay, then similarly you can have a data set of your network traffic, say under attack, right? Say under any web application attack, or say your password based attack or DOS attacks, right? So like that way you can create the data sets. So what the algorithms will do here, these AI algorithms, they will see these patterns over here. Okay, what does a normal network traffic look like? Okay, then it will see what does your, if your systems are under attack, right? If your organization is under attack, then what the network traffic will look like, right? So then they are trained in the training phase, they will understand this pattern over here. Okay, this pattern recognition. So that is why we say, like, well, you must have heard that we are training these AI models over here. So what are we training for? So say whatever the use case, say if we are using them for detecting these attacks over here. So then in the training phase, They are taught that what a normal looks like, what attack based traffic looks like, right? So then what happens whenever the once you trained your model and once you deploy the trained model, once you have deployed it, then it can work in your real time network traffic. It will see, okay, if something is normal, then it won't raise the alert, and if something is out of the blue over here, right, or if it has found some traffic that is resembling what it had learned in training, what it had learned that this is attack traffic, so then it will raise the alerts. Okay, so now it is up to us that with what we want to integrate this, right? Say if we are building a model for detecting the phishing emails, right? So then we can integrate this model with your email clients. In case you have developed this network anomaly detector or model for detecting these attacks, then say you can integrate it even with your SIM tools. So you will get more visibility in your SOC environment, right? Manually, we don't need to see those logs that are there, right? Even if like, there are interesting fields and it has already been sorted out, but AI can help you sort them out further, right? They can even manually try, so you can even automate the triaging process, right? Based on how critical that particular attack is there. Okay, so this is how in our data, our models, our AI algorithms are trained to recognize these patterns. Okay, and all this, what makes AI different from your traditional rule-based systems? Because see, whether be it your anti-malwares, right? Anti-malwares are functioning on those. How do anti-malwares work? You all know the working of anti-malware. So traditionally till now, so if you have a anti-malware or antivirus, so how is it able to detect that, okay, this file is malicious? Signature based. Anti-malwares traditionally they have been signature based, and signatures are nothing but the hash values of your files. Right, every file they have some hash value associated with them. Okay, so these anti-malware organizations or this particular tool that they have, the anti-malware, they are maintaining a database of all these signatures, right? But now, how can this signature-based detection be bypassed? Right, so see, whether you're talking about anti-malware, whether you're talking about intrusion detection systems or intrusion prevention systems, traditionally they all have been rule-based. Okay, either they are looking at the hash values over there, the signature values, or they are looking at some DOS rules. Okay, if this particular thing is satisfied, then do this, right? If else programming part, this kind of things. Okay, so now if you make some minute changes, say you have your malware code, and in that, the person who has developed that code, the script, the malware script, he makes just some minute changes, right? So what will happen with this minute change in that malware code? The entire signature changes. Okay, so if this signature or the hash value of that particular malware file will change, then it will go undetected by our rule-based systems, right? But since AI systems are working on this pattern recognition, right? It is not dependent on those signature values over there. It is seeing the exact, it will see the behavior of the malware, or it will even see some things related to the malware images. You can convert malware to their hex form and then convert them into images, right? So in reality, the pattern has not changed that much. Right, the pattern has not changed that much, but your rule-based detection systems can even miss out minute changes in patterns. I'm writing down a rule base, they can miss out minute changes in patterns. Okay, so that is the advantage of these AI based systems that we have here. These minute changes won't go undetected. Okay, and what they have, since your new data is coming in, okay, so what you can do, you can even retrain your models based on this new data. Okay, because with time, maybe the types of network attacks are coming. So if they are slightly their pattern is varying, so they can be caught. But if there are major changes in the attack pattern, so what we can do, our training data over there will be updated accordingly, and you can detect these also, right? So because of these AI systems, they are very important in cybersecurity. Okay, so now coming to these core components that we have. So say if you want to build any AI model, the pattern recognition is in data, right? So you require some data set, right? Or like one data set that I showed you over here. Okay, so data is there, and in by infrastructure, what do you mean, Gaurav? So Swati, LLMs are the models that we have, right? LLMs, you can say, are the end product which we all use. So the question here is that how are these LLMs created? What are the core components for that? Okay, so another thing that we can put here are algorithms. Yep, you're saying infrastructure, architecture over here. Yeah, see, architecture will include everything over there, that what, how, what all algorithms you're using, right? Because they can be complex. As we'll see, we can have simple algorithms also. And as with the case of generative AI, we say that we have a more complex structure. So there we are using a combination of algorithms to create that architecture. Right, but still the core component is the algorithm only for that. So you have data, you have algorithm. We are just left with one more thing. What can that be? So someone said earlier, along with data, you said infrastructure. I thought with infrastructure, I think you meant some things such as like these GPUs, the presence of these GPUs, right? You all have missed out this GPU part over here. This NVIDIA stocks are all rising since. So anyone who must have benefited or not, but Nvidia certainly has benefited over here, right? And why? Because they provide another core component for that, and that is our computing power. Yes, exactly. Processors to process the data. So traditionally, we were using for machine. If the algorithms are not that complex and data is not that much, then you can use your CPU also. But nowadays, like for developing these LLMs, you require the GPUs for that. Yes, Parvati, policies, compliance, all these things will come when you consider all the security considerations into these things, right? That how where all AI cannot be used for, what you should not use them for, or how to develop them safely. So to monitor all these things that they have been developed and deployed safely, then all these policies and compliance things will come into play. Right, so these are core components that we have here. Data in the form of data collection, that why we are doing that data collection, what is the importance of that data set that we have already seen, because you need to study some pattern, you need to teach that AI model that what a normal attack looks like, what a malicious attack looks like, right? So for that we need some data set, okay? And then we have these algorithms too. Okay, so who sees the things? Who sees the pattern in the data? Those are your algorithms. Okay, and finally, for creating your final model, like the model that has the ability to even predict, right, based on data and algorithm, right? We get an AI model. So now this AI model has learned from the historical data over here, and how it is able to learn because of the algorithm, right? And for this algorithm to learn from this data, you require that computing power. I'm saying compute required for algorithm to learn from data. Finally, we get the AI model over here, and this AI model is even able to do the predictive analysis. It is able to predict the things. That way, we are not just dependent on some rule-based tools over here, right? That will say just when the attack has happened, then only it will respond over there. No, we can even predict based on the incoming traffic over here. Like we can look not only for the indicator of attacks, but we can even look for the indicator of compromises, right? That if someone is even scanning our system over there, right, even preparing for the attack, then also we can come to know with that, right? And with this predictive analytics, since we are able to predict the things, that's why it is even easier to automate our tasks. Okay, and now see, based on these algorithms that we are using over here, we will have our different types of AIs, right? So these neural network, deep learning, all these things, we'll try to just demystify all these things to you. Okay, so you'll come across all these terms over here. So you must have seen something like, okay, we have our artificial intelligence, right? And see, artificial intelligence is a different field, and even data science is a different field, but both of them intersect. Since we are saying that AI models, they require data to work, data is one of their core component. So when we are collecting our data, we need to transform it also. We need to pre-process it. We need to make it suitable for our AI model, for the AI algorithms that is there. Right? We need to make it suitable so that the algorithms can understand what is going on. Right? So for making them suitable, we need to do the pre-processing steps that we have. Right? And all that pre-processing steps requires the data science or the data engineering abilities, capabilities, right? And then over here, so as I mentioned, these things are core components that are data, the algorithms that we have, okay, and of course the computing also, compute power. So now, based on the algorithms that we have here, you will see different types of AI. What all different types are there? Okay, so machine learning is one of them. Then you also have your deep learning, and what you're seeing nowadays, that is the generative AI. Okay, so where all they stand over here? So for machine learning, you can say it is nothing but a subset of your AI systems that you're building. And mostly the algorithms that are used here are your either statistical or probabilistic in nature. Okay, so we can say here in machine learning, for the machine learning algorithms, if we are using, these algorithms are mostly statistical and probabilistic in nature. So many of the things like, see, this linear regression, logistic regression, you will see over here. Some things such as your support vector machine, right? The naive Bayes is nothing but based on the Bayes theorem, right? You must have studied this if you had mathematics, and like maybe even your 10th or 11th class, you had this Bayes theorem over there. So just for that, because you know you're developing this predictive systems over here, right? So these in the end, they are these AI models, they're not some like very fanciful thing or some magic that is happening inside. You can just say just some mathematical functions you're using out there, and then you're using them in a very smart way. Okay, so now what we'll have here, if you're making use of the neural networks, right, then we call it as deep learning, right? So in deep learning, I'm writing down this uses the neural networks, right? And specifically the artificial neural networks. Right. So in deep learning also you'll see various types like your multi-layer perceptron, your CNN model, your RNN model. Okay. So you can see these artificial neural networks. So by the way, like our human brain that is there. So what is the fundamental building block of the human brain? What are they made of? Or what are those cells called? Which cells make up our human brains? You're aware about them? Neurons. Exactly. Exactly. So in one way here we are inspired by the structure and working of the neurons, right? Just like how in neurons you must have seen if you had biology ever, uh, some like this, there is this cell body over here, but it has some these branches over here, okay, in one end. Okay, forgive me for the drawing, it's very pathetic, but they have some branches like this. Okay, and then they have a long tail like structure over here, right? And in the end they have some structure like this over here. Okay, so this end part of it is connecting to further neurons, right? This part, this is the starting part. So this part of another neuron is connected to this axons part of it again, right? You have these dendrites over here, you have the axons in the end, right? So this you can say as something taking, because in the end our brain also it is working on the minute tiny electronic signals are there, right, which in turn are getting converted to your chemical energy, all that, right? So then you have your cell body where your processing is taking place. So just like that, the neural networks are also inspired by this. They have this input layer, okay, where you'll have different nodes over here. Then the processing will take place in the hidden layer. So for neural networks, when the artificial neural networks, it is mandatory to have at least two hidden layers. Right? So you have these hidden layers over here, and then just like these axons over here, you'll have the output layer also. Okay, so whichever algorithm are using these new artificial neural networks, if it is using the artificial neural networks, we will call them as deep learning. Okay, your traditional one, these which are only using the statistical and probabilistic algorithms, any function like that. So that is your machine learning. Okay, and finally this generative AI over here, here we can say it is using a combination of your deep learning models and machine learning models. Right, that's why we are seeing the architecture also what we are designing. So for uh, GPT ones, these chat GPTs, we have the transformer architecture over there, right, which are even making use of the multi-layer perceptrons. It is even making use of RNN within it, right? It has this attention mechanisms, right? So different machine learning and deep learning models, you're just combining them, you're designing them, and then that way it will say that okay, what kind of data input will come in, what kind of output will come in, right? So these generative AI models, what we are making, they're mostly, see, this term is there, generative. They're generative in nature. It means they can create something from scratch, right? They can create anything. They can create text, new text, right? They can create code for you. They can create images for you. Okay, so that's why we are calling it generative AI. And within this generative AI also, so it only started with something called as this variational autoencoders. Then we had these generative adversarial networks also, we call them. So they are all part of generative AI. Then you have your small language models and LLMs, large language models. Right. So now I hope this thing is demystified to you, like what is machine learning, deep learning, generative AI, where do LLMs stand over here? Right. And see, agentic AI is completely something different field that we have. Right. We have agentic AI also. So what agentic AI is doing, it is something that can use this. It can either use deep learning tools, it can even use generative AI tools. We give them the LLMs also, right? So we give them one goal, right? What goal it has to achieve. Plus, for achieving that goal, we give it some tools, right? And so that it doesn't do anything, something intended, unintended, we need to perform the context engineering also over here, right? So these are some terms all related with AI. And yeah, this thing also you can see here that okay, machine learning, then deep learning is specifically that kind of machine learning that is using only neural networks over here. Right? That's why we have the deep learning. And generative AI is will come further under this. Right? It is more specific. Okay, then you must have seen something called as your natural language processing also. So natural language processing also is something, a different field that can be used in AI. Right, so wherever you have your text related data, you can use it for creating the models over there. So for that, we can even use this natural language processing. Okay, so see, these are some terms that are associated with the AI that you need to keep in mind before we proceed further. Okay, so now we have seen that data part also. We'll see that okay, what all algorithms are used, right? So from that we have these learning types. So now when we are building the machine learning algorithms over here, we are building machine learning. So then you have options, right? So see, this is this thing what I'm telling you about now: supervised, unsupervised, semi-supervised, reinforcement learning. All these will be part of your, since they're part of machine learning also, and since we have seen that deep learning over here is a further subset of machine learning, right? So we can say these things, supervised, unsupervised, semi-supervised, reinforcement, they are applicable for your machine learning also, and they are applicable for your deep learning also, right? So these are the learning types. These are not the types of algorithms. The types of algorithms, what I told you, are these. These are the types of algorithms like your logistic regression, support vector machines, naive Bayes, right? K nearest neighbors, many more. There are these machine learning algorithms. These are your deep learning algorithms, MLP, CNN, RNN, right? But the way in which we want to teach these algorithms, right? The way we are teaching them, that is called the learning type. So within machine learning and deep learning, we have something called as the supervised learning. And supervised learning means we provide them with labels. So you will have the data set also, and along with that, we will have something called as the labels also. What does this mean, labels? Okay, so I will show you one. So this particular data set, what I showed to you. See, these things are the features, what you can see on top. Your number, time, source, destination, protocol, length, other information. All these are your features of your data set. Now just imagine this side, if I had one more column and say if I had named them labels or type or something like that, right? If I'll name something as labels over here, and corresponding to this, I'll write down, say, instead of writing malicious and normal, since computers they understand numbers better, so I will just write down ones and zeros over here. So say if I'm writing down zero, so zero can mean for something that is normal, and say if I am writing down one over here, so then I know, okay, that this particular packet that we have is representing something malicious, right? So it is, we are giving a one over here, right? So see, in the end, our computers that are there, that are working on this data, and even the algorithms that are there that are working on this data, they don't have the concept of normal or malicious, right? What concept they have? They have the concept of one and zero over here, right? One, zero, or two, or whatever features. If you have multiple classes, then so on, right? Different labels. So in the end, when I said that pattern recognition, that it identifies what is normal and what is malicious. In the end, here what it is identifying what a label one looks like, what a label zero looks like. Right. So I'll show you one label data set also. Okay. So this side, you can see it is, you have some messages over here. They can either be normal messages or they can either be spam messages, right? So in one column you have the messages, and in your other column, see, you have the labels, right? So wherever you're seeing zero, that is indicating this is a normal message, and wherever you have one, right, that is, you can see that is a spam message in this case. Okay, so this, we can say this is our label data set, and any algorithm where we are giving this data set over there, right? There we will have, first of all, have to choose some supervised algorithm, right? And the AI model that will be created with this learning, it will be called, that will say that it is using supervised learning, since we have provided it with labels. Okay, but in some cases, what we do, we don't provide our data with the labels over there. So what we do, we use the clustering algorithms over here. Okay, so say like, simple as that. Say if you have, so we are doing unsupervised learning on a daily basis also. So say you just have some, your wardrobe over there. Okay, in that wardrobe, say you have different pair of clothes. Say, one are the pants that you have, right? And say after just washing, you had just clustered them in one place. Okay, and one of that, like say some are your pants, some of them are your shirts, right? So what you'll do, say you want to arrange your wardrobe properly. So then in that case, you will be able to identify easily that yes, what pants look like, what your shirts look like, and then you will place them in order. Okay, so similarly, these algorithms also, what they are saying, say we are just giving them data over there, and they will see, because your normal data and your malicious data, they might look different there in most of the cases. Okay, so there also you can see this, say one set of data will be just clustered there. So say if you are just making the graphical representation of your data, right? So one set of data will be clustered in one place, and say another data that is appearing different, that has different patterns, that will be clustered in another place. Right, so that way your unsupervised learning is working without labels also. And then you have semi-supervised learning also. So semi-supervised learning, what is happening? You have, say, your data set over here, right? And data set has all its features. So say you have this data set, and within them you have the features that are all the columns except your labels column. Okay, so you have your features column over here, and based on these features you have to make the labels. So initially what happens, just you're labeling some of them. Okay, then rest of your data is labeled on its own using, so because by now we'll realize, okay, what a 1 looks like, what a 0 looks like. So based on this pattern we are using the pattern recognition earlier, in an earlier stage only here, just to label your remaining data. Okay, so your algorithm itself labels the remaining data. Okay, that is our semi-supervised learning, where some part labeling we are doing and then the algorithm is labeling your remaining data. Then we also have this reinforcement learning, right? So you must have heard of some these game playing robots. So in 1997, how that there was this IBM's bot only called as Deep Blue. Okay, so it beat that at that time the chess champion was Gary Kasparov, one of the best player at that time. So it beat him, and then after that they were saying that okay, chess machines can still beat the humans. They were saying that we will say that these systems are actually smart when they beat, say, a person, any person in the game of Go, right? So that chess compared to Go has lesser permutations and combinations. Your Go over here, they say that it has hundreds of thousand, at least 1,000 times more permutations and combinations that was there in chess. So just by some steps or teaching the models with some data, it was not enough, right? They said that with this, if they beat a humans, then they will truly understand that they have immense learning power, your AI systems, right? So in 2017, this they created a system called as AlphaGo, and it beat the best Go player at that time. Okay, and it played such kinds of moves that no human had ever played. Right? So you're seeing how these models they have that learning capability also. Like initially when we discussed over here, the ability to learn and adapt. Right. So how these reinforcement systems are having this ability to learn and adapt over here, right? So such because they're creating such moves that even a human has not seen, right? After seeing that particular move, that particular Go champion, he took retirement from Go just by seeing that, right? And he himself said that this move was very beautiful. Okay, so how it's able to learn is because these game playing robots, or even the robotics, when you're using them in robotics also, so what you're doing, they are playing several games with themselves. The model is playing the games with themselves only. Okay, and what you're doing here, you're creating something called as a reward function. Right? There is an optimum function that you need to reach, and there are something called as the reward points and the punishment points. Okay, so just like how some parents might think that okay, this is a it's a good way to reward and punish the child. Like I'm not saying everyone are doing this way, but they're just like some way they're teaching their child. These models are also they are taught with the same approach. Okay, so they're playing these games with themselves, and if they're losing, okay, so in the end their goal is just to win the game over there. Okay, so if they're losing, so what happens, punishment point is given, and finally this reward function here, it is reduced. Okay, then say if they're winning, this reward function here will increase, right? In the end they have to reach some optimum level. So whenever they're losing, they will see, okay, they'll analyze what went wrong and they'll say, okay, these are the things that we are not supposed to do. Okay, and whenever they are winning over there, they'll see that, okay, these are the things that we are incentivized for, these are the things we need to replicate and perform better over here in these aspects, right? That's why they are playing thousands of games with themselves only, and they are able to improve after every step, right? And the end, they are becoming so good that they are becoming better than humans in this game playing tasks. Okay, so same goes for robotics. They are, say if their task is to say walk in a straight line or lift up some box and keep it in another place, right? So for this simple task only, initially they won't be able to do, right? So that's why the punishment points are given, and then they know, okay, what thing they have to not do this, they have to do this in some other way, right? So that's how they learn the correct way of doing things, and then later on what they're doing, they're even improving upon the new ways that are the existing ways that are there, right? So same goes for autonomous vehicles also. Say if you want to go there, you want to detect the obstacles, you teach it when to stop, teach it when to go, right? Teach it when to increase speed. So for all this we have the reinforcement learning also here, right? Then now when you're coming to deep learning, so here I told you different types were there here, right? These MLP, CNNs, RNNs. Okay, so when you've built your traditional model over here, right? When told you that these neural networks, the deep learning is nothing but they work with these neural networks. So in their most simplest form, you create something known as a multi-layer perceptron. Okay, perceptron over here, it is something that is replicating a individual neuron. Okay, real neuron, it is imitating it in some way, and when you're using multiple layers of them, you call it as the multi-layer perceptron, right? So this is your most simplest form of deep learning, right? And then you have your conventional neural networks, right? So this, what it will take in the image inputs, right? So this is nothing like giving the AI models the power to see. Right? This is how your AI models, they get the power to see using these convolutional neural networks. Right, so that's why you can say they are used for image recognition, also video analysis, even for your medical imaging tasks. We can make use of this CNNs, even for your self-driving cars, right? So self-driving cars are nothing but the combination of CNN models and using reinforcement learning over there. Right, and as I told you, these supervised, unsupervised, semi-supervised reinforcement, they can be there for your machine learning algorithms also, and your CNNs also. Sorry, your deep learning also. Right, so that's why we say if you're making the autonomous vehicles, they are using this CNN, and the learning type there is reinforcement learning. Okay, so you can say for autonomous vehicle, the algorithm used is CNN, right? So these are all the deep learning algorithms. Okay, so self-driving cars is using the CNN algorithm along with, and the learning type that it has is reinforcement learning. Okay, then recurrent neural networks will work very good with these time series data. Time series means when you're collecting data over a very large period of time, right? So because of this reason, these RNNs are very effective for creating the network anomaly detectors. Why? Because there you need that network data that is spanning for days, right? For a period of days it is spanning. Okay, you need to collect that data over there, right? And then on that, we'll use the RNN on this data for building our final model, right? For that, of course, we'll be using the some GPUs over here, right? That GPUs will help this RNN algorithm to visualize this data, to understand the patterns in this data, and finally we'll get a new model which can work for your new incoming data also. There it can do the predictions that whether is this some normal data, whether is this some malicious data. Okay. So then I also mentioned this natural language processing. Natural language processing means, say, when, so tell me, in your, for your cybersecurity use cases, where all will you deal with text data? So some PIIs of some people, like if they're in text form and you're anonymizing this, okay. Text data in answer file or host file on server, or mhm. Yeah, but exactly what text data? So can I say, when you're looking at the threat intel reports, there you can deal with the text data. Yes, Ramsey, emails. Okay, because see, we have we have to make something. If we want to do the phishing detection, we need to feed the emails over there, right? It should know what that normal. So you saw that data set on that spam emails. So that was a data set that had text data in it, right? So any data set where you have your data set where it is using text data. Okay, so if you see this data set here, you don't have much text, right? You just have numbers, continuous numbers over here. So I wouldn't prefer NLP for this particular data set, natural language processing. But for this data set, I know I just have this text related data over here and just the labels. Okay, so here definitely I will make use of my natural language processing. Okay. Yes, Innocent. In your SIM also, you are dealing with the text related data. So say, because there are logs, right? So logs are also there in the form of text. Captured file, yeah, that is dot .pcap file. So this thing, you might, that for this Wireshark capture that I've shown you, that is just a pcap file which I have converted it into my CSV file. Right. So for emails, logs, and even for reporting, where when you're dealing with reports out there, right? So if you want to summarize the reports, extract the meaningful information from your reports, right? There it is a no-brainer to use the natural language processing. Okay, so this natural language, as we'll see later in our model development phase, I'll show you in which phase we are using the natural language processing, where it is required to use this, right, and where it will be helpful. Okay, so we have already seen as we told you, a complete SWOT analysis we'll be doing. So these AI strengths that are there, where we can use them in cybersecurity, why we should use them is because, see, attacks now, they are faster, they are stealthier, means they are evasive, right? They are evading our IDS, the anti-malwares. Okay, they are going undetected. So your rule-based approach that you're following, they are not able to detect the attacks, right? And also the attackers, they are making use of AI to do their attacks quickly, right? So now, cybersecurity over here is all about speed. So say there is some new vulnerability that is being found, right? So I'm sure you all are aware about these new CVSS scores, new CVs, right? Common vulnerabilities and enumerations that are there. Okay, so say when new vulnerabilities are found, what you need to do, see, attackers, what they can do, they know, okay, yeah, this is a particular system, this is, and now there is enough reconnaissance techniques that you know which organization is using which component over there, right? There are so many, like if you study ethical hacking also, you'll say there are so many ways to do that reconnaissance over there. Okay, so they know, okay, if some new CV is found that, okay, Node.js vulnerability is there, this new thing. Okay, so then what they'll do, they know, okay, now these other organizations, they will patch this. So now it's all about how quickly you can patch that system. So say if you're still following the traditional approach, right? Manually you're doing the things, or say if you're automating things with the script also, right? So still that will be slower. But with AI, as you all mentioned, automation, you can make that automation even more efficient, even more faster over here. Okay, so because now attackers, since they're using AI to attack, so the way they're attacking is also fast. They can quickly, multiple attacks they can do, right? Multiple vectors they can launch, multiple exploits can be done for these vulnerabilities simultaneously by them, right? So since cyber defense is all about our speed, that's why we are transitioning towards our response part also with you by using the AI. Okay, so as we see the legacy tools, when we are talking about the older tools for which legacy systems, we say for which the support is not there. So here in this case, legacy tools, we are just saying for the older rule based tools that we have. Okay, so for the rule based approach, they cannot keep up with your AI powered phishing. Like you can generate phishing mails at a very rapid pace, right? Realistic looking emails. Like earlier, we used to teach that, okay, there will be some grammatical errors if it is a phishing mail, but now not anymore, since you're using AI tools to generate the phishing. So you will not find the grammatical errors in the phishing mails. Okay, and you can even generate the malwares with that. Okay, 0 day attacks. What are 0 day? 0 days have no known patch, yes, because they are unknown. Okay, so the idea here is when you're talking about 0 day, it means something that even the developers of that particular software or that particular security control that you're using, even the developers and the testers also, they don't know that this vulnerability even exists. Okay, even so, the devs, developer, and testers, they don't know the vulnerability exists. Okay, no one is aware about this vulnerability. You know, the vulnerability assessments are taking place in your organizations. Okay, so within them also, they have not found out this vulnerability at all. Okay, so the first person to find out about this vulnerability is always the attacker in this case. Okay, so whenever this 0 day vulnerability is exploited, we call it as a 0 day attack. Okay, so now when that 0 day attack has happened, so you know that, okay, this is a completely unknown vulnerability. So, of course, there will be no patches also available, right? So, these 0 day vulnerabilities now suddenly it's out in the market, it's out in the wild. People know it. Okay, now there is this 0 day vulnerability for so and so system. So, now these systems can be exploited. Okay, so say there is a 0 day vulnerability just in some tool of Microsoft over there. Okay, so any organization that are using these tools are now under threat over here because there is no existing patch also available for that. If the patch, there will be some time taken to create a patch for it. So in within that time period, these vulnerabilities can be exploited by these attackers. Okay, so now see if when we are making these AI systems over here, there is something known as anomaly detection in AI. So what you're doing, you're training your data, you're training your model, and you're teaching your model that what a normal network traffic will look like, right? And that way a baseline will be created. baseline is something that is normal. Okay. With so what we are doing, we are building these AI models, and they will know what this baseline or what this normal looks like, right? But now, if there is anything mm, not matching this baseline, right? If some network traffic is coming in and that is not matching this baseline, we will say that that is anomalous, right? Because the AI models, they are trained to detect this baseline. In this case, anything deviating from this, the alerts can be raised. So, right, though in this approach there will be false positives also, they will increase, but at least even the zero-day attacks can be identified because they will see, okay, now some the kind of attack network traffic is coming in that is not matching our baseline, right? So that way we can even detect the zero-day attacks. Right. I'm not saying that all every time it will be successful, but the percentage, the rate of detecting these zero-day attacks will drastically it will go up. Right. And remember, this is an important thing over here, as you will see in our weaknesses of our AI systems. Due to the weaknesses, we are not only using the AI systems, we are using a combinations. We are using a combination of rule-based plus learning-based approach. Right. So our rule-based prediction is not that we have gotten rid of them. No, we are still using them, but what we have done, we have augmented this AI with them, right? So that we can have even better detection. Okay, so this way we will be able to detect even things such as the advanced persistent threats. They stay undetected in our networks because mostly these are the threat groups, mostly hired by APT groups. They are hired by the nation state actors. So they are doing these cyber attacks in a very, like, they have a lot of funding behind them, right? And they have all those advanced tools. They have no lack of the human power with the human manpower, right? No lack of resources, right? So that way they have enough time to do such in-depth reconnaissance and create such kind of malwares that will go completely undetected by the systems, right? And their target there is to remain undetected and say like spy on their target organization and exfilter out the data. Okay, so you must have heard about the Sony picture hacks also, or even the Solar Winds supply chain attack that was there. Okay, so it was the Solar Wind attacks was said to be done by a Russian APT group. It- So what they did there, they even targeted the solar winds and which were supplying lots of Fortune 500 companies, organizations with the security products. So now since the solar winds was targeted, so then they started supplying them with the faulty security products, and that way this attack it remained undetected for over a year. Okay, and all that they were able to spy on so many organizations because of this reason, right? So if they had been using AI, there was a chance that you could detect these. So there, how we will detect them? There is something called as behavioral analysis. So these, for your AI systems, these anomaly detection and behavioral analysis are very important, right? What we can do, we can create something called as user and entity behavior analytics, UEBA we call it, and that gives it. So there also we are following this baseline approach only. We need lots of data over there for the training of these models, and what they're doing, they can identify whether these systems are acting normal or in an abnormal way, right? So if they are exfiltering out the data, right, so in that case there is a chance that the APTs can also be detected by studying the behavioral pattern of how a normal device is supposed to behave, and if it is exfiltering out data, and if there is some rootkits present inside them, then how that system behaves. Okay, so you've seen all these things, AI powered attacks like deep fakes, okay, autonomous phishing, self-evolving malware, all these things are there, right? So by the way, these deep fakes, they can also be created using these generative adversarial networks we have. So generative adversarial networks, it comes within your generative AI only. So here what you're doing, you're using something as some one neural network here is called the generator. Another neural network here is called the discriminator. So what we are doing, we are feeding it some real data with it. Say this real data will be someone's voice or some image or someone's some video. Okay. So what this generator will do, it will try to create this real data. And there will be a adversarial game played between this discriminator and generator, where this discriminator will try to catch the generator. Yep, that your data that you are generating is completely wrong, it is not matching this real data, and it will give it a feedback, yes, I have caught you, right? And that way, from this feedback, this generator will keep on improving upon its performances over here, right? In the end, like, there will be a time where the discriminator won't be able to identify the difference between the generated data and real data, right? So this is how these deep fakes are created. Like video you can create that way, images you can create, voice clones you can create this way, right? Art generation, all this thing, and image generation you can do. And not just that, it can be used to create synthetic data sets also. So it can be used for both good and for bad, these generative adversarial networks that we have here. Okay, so you're seeing that these things, you have the AI powered attacks, deep fakes, autonomous phishings, self-evolving malwares, polymorphic malwares, right? That can evade the detection, right? So to stay in touch with the attackers, I mean, from our defensive side also in our cyber defense, we need to make use of these AI models, right? The AI security controls, we need to make use of them, right? And we have already seen the strengths that why we are using them. Okay, there's why we need it further, because we have more and more devices over here, right? We have so many IoT devices we are connecting. Now after COVID, the BYOD policy, that bring your own devices, have only increased in the organization. Okay, so because of that, we need, and see, you're using lots of third party applications, your system as a software SaaS products that you're using, right? So you need this UEBA, user and entity behavior analytics. You need the behavior analytics of the system. You need to know what a normal system will behave like, a normal user will behave like, what abnormal system, or if some insider threat is there that you want to detect, what will that if insider threat is there, then how that system, what kind of commands will come from that, what will your network traffic from that look like, right? So all these things, since we have our AI models can detect all these things, that's why we are supposed to use these AI security controls also. Okay, so this we have seen already, that traditional security, how it is reactive in this way, that when the attack happens, then only you're reacting. But now, here with these models, you're trying to create such models that can even look at the indicators of compromises, right? Even before the attack is about to happen, that how you can look at those signals, right? You can look at how the minute changes also. As I said, rule based ones are not able to detect the minute changes, but AI based systems can detect your minute changes. So because of that, our reaction, like our incident response, it becomes more proactive, right? We can take the proactive measures right before the attackers has even gained access of our system. Okay, so this part we had seen how your traditional ones were signature-based detection. You had also rightly pointed out how your anti-malwares, they are working on signature-based approach, because anything, you can mutate these malwares slightly, so you can change the pattern slightly, which your traditional tools will miss out. Okay, earlier you used to do the manual triage in your SOC teams, but now AI can automate this, right? You don't need the delayed response, you can quickly automate the triaging in that way, right? Triage, I hope you are aware what triage means, this part. Different threats we found out, different, say some threat or some attack is happening over there, right? So what the L1 analyst, SOC analyst is doing, they're prioritizing, okay, this one is more severe, this threat, and this one is less severe, let's place it down, right? And then this thing they will send it to the L2 analyst, to the incident responders, right? Then they will see that, okay, what is worth responding to first, and then these kind of things, right? So this thing, the triaging part, what is there, can be done automatically, right? We can automate this part. Okay, then we've seen with your traditional base, there is no behavior analytics. So now with AI, we have this user and entity behavior analytics, right, which we've seen earlier. So that way, it was very difficult to detect the insider threats or any malicious system, or that there are, like, when someone is doing a cyber attack. Okay, someone can attack from outside the network also. There are different ways outside network, right? Mostly the web application based attacks or any vulnerabilities there in some tool that you're using that can be exploited. Another way of doing is like even from inside the network, right? So say if they've breached the security, right? And then inside, say, somewhere they have connected their malicious device. They've connected their own device, right? If you have seen that series, this was there, it was called as Mr. Robot, right? Anyone seen this? So there was a scene there where that hacker had connected the Raspberry Pi, right, inside that data center. Yes, Mark. Right. So you must be remembering that scene where they connected that Raspberry Pi over there, right? And then from some remote system over there, they were able to control this Raspberry Pi, and via this Raspberry Pi, they were able to send the malicious commands, right? Because once you're inside the network, there doing the cyber attacks are way easier once you're inside there. Right, doing from outside it is a bit difficult, right? But that is a separate thing, that if there is a vulnerability that can be exploited from outside, so that is a greater vulnerability. Okay, but generally, say if it is a very secure environment like your data center, there hardly you will find, like, unless there is a zero-day vulnerability, right? Apart from that, you won't find any vulnerabilities that are there that can be exploited from outside the network. Okay, and generally, if you want to exploit the system, say you need to you need to compromise a device, right? Either you will put your own compromised device there, or you will force the user to compromise the device. Tell me a technique. So in the end, see, either it is the existing security flaws in the security controls that are there that can be exploited, or as we say in cybersecurity, we say humans are the weakest link. Humans themselves are an attack surface, right? So if no matter how many security controls you put up, one human ends up putting a infected USB somewhere, or ends up clicking on a phishing link, all your security controls go down the drain, right? So for detecting this, so first of all, we can have AI for blocking the phishing mails itself, right? The phishing mails won't be received by that human. And in case, for due to some reason, these employees have compromised their own device, what can this user and entity behavior analytics, it can easily identify, okay, this device is behaving in an abnormal way, right? And it will recommend to isolate that particular device. Okay. So you've seen here, traditionally you have lots of tools, siloed tools over here, but AI is just bringing a common platform over here in that case. Okay. Alerts, you can be overwhelmed with false positives also, right? Though in some cases in AI, this case is also there, like when you're following this baseline detection. So here also, if your data quality is not that appropriate, in AI also you will have this false positives. Okay. Then you have limited visibility traditionally, like blind spots in your environment, right? And then there is a perimetric centric mindset in your traditional tools, that yes, okay, if there is a firewall or IDS over here, okay, just in the perimeter we will keep this over here, right? Or you can have firewall, say, for your system maximum. But with user and entity behavioral analytics, what we are doing, it is a prerequisite for our zero trust systems, right? So there are many zero trust products which need the use of AI over there. right? So this zero trust, we have seen that it is continuously verifying there, right? Never trust, continuously verify, right? Or say trust only after verifying the user behavior or the device behavior. So how is that possible? It is possible by using these AI techniques such as user and entity behavior analytics. Right? That's why we are able to apply the zero trust and move away from the perimetric centric mindset that we have with a traditional rule based approach. Right, so now we'll see that AI models, how you can use them as a security controls for your organizations, how you can use this AI and where all you can use them for. So many places are there. We are seeing most of them over here that you can see. See, you can use it as network anomaly detector. Okay, so this part we had seen a little bit that how it can learn from normal traffic and it can flag any deviations from that. So it can detect things such as your data exfiltration, also your DOS attacks, DDoS attacks, web-based attacks, all these things. For email security also, you can use it. So what you can do, you can use natural language processing for it and then train the model to for it to detect. So we'll teach it that what normal emails look like, and we will teach it what your phishing or spam emails also looks like. So for your email security, not just the emails, you can even do the link analysis, right? So you can have a data set that is full of malicious links, right? How does a phishing link look like? And then one data set you'll have here, like how your normal links look like, right? So I'll show this thing that I showed you over here. This was your text related data. So this you can say is for the body of your emails, right? But what we can do, we can create a bigger project that will detect everything. So for text analysis, we can use this. Then say for link analysis, I will show you another data set over here. So what I have here, this is a kind of structured data set that I have. Okay, where I don't have text, I just have these one zeros or minus one written over here. And you can see various features are there of a link, right? Because generally if the link doesn't has a domain name, if it just has an IP address, there may be a possibility that it can contain a trojan over there, right? Why are we getting a link with only a IP address, right? Sometimes the attackers, what they're doing, they're increasing the URL length, the link length, just to hide the malicious part in it. Okay, so if the URL length is very long, that can be one of the features. Sometimes what they're doing, to hide a suspicious email, they are using these shortening services like bit.ly, go.gl, something like this, right? Tiny URL, all these things. So if these are present, that can also be one indication, right? For redirecting, we can use at the rate symbol. So some part of your website will represent a known domain name, and after that, at the rate, your malicious link. So that what when we are using email, the links in this type, the first part is neglected, only the part after at the rate that is uh, seen over there, right? That is considered. Same goes for double slash, right? Similarly, these are many features that we have, that how your links look like. And say in this case, your structured data set was a list of email, sorry, your unstructured data set was a list of links. Okay, now that's unstructured data set, we are converting it into this structured data set of rows and columns, right? So if it has IP address, so we can say 1 and minus 1 according to that, right? 1 we can say okay, yes, it has the IP address. Minus 1 we can say no, it doesn't have, right? And in the end you can say this result column is nothing but your labels, right? Ones and minus 1 indicating whether it is a phishing link or normal link, right? So we can even do the link analysis, we can even do the attachment analysis, right? So the malware detection, so how whether that attachment contains a malware or no, right? So you can combine all these three things and create a project for your email security and integrate them with your email clients also. Okay, then this part, as I mentioned, user and entity behavior analytics is very important even from your zero trust point of view, right? So what it does, builds a baseline for your users, for your devices, right? How a normal user should behave, how the normal device should behave. Okay, and then it detects for any unusual logins or file access patterns that way, right? In that way, it can even identify the insider threats. Okay, then where all you can use them, you can use them as a security control for your endpoint protection and malware detection also. Okay, because it is going beyond your signature based analysis. Here what we are doing, learning based analysis. So what you can do, you can study the behavior also of that particular malware, right? It can analyze that what a malicious file actually behaves like. Okay, and you can even do the heuristic analysis where you're converting the malwares into a hex code, and anything that is in hex can be converted to binary also. And since you have that binary code of it, that can be converted into something of like a black and white image, right? So without even analyzing, because behavioral based analysis is a bit risky. Okay, so without doing that, without taking the risk, just by converting the malware into images, you can directly detect whether this is a malware or no, right? So it can detect your ransomware, fileless malware also, right? And then of course in your user and data security also, it is very important. You can use them as a security control for monitoring your data loss prevention, right? It can detect the misconfigurations in your system, right? That's why for application security also it is very important, right? It monitors the login typing. So when we are talking about UEBA, it can even monitor like your uh, password. So there is one project that we have made here is like identifying the keystroke detection. So now if someone gets access to your password, so if they're not typing it in your typing style, they won't be able to log in with the correct password also. Right, so you know that there will be some physical perimeter over there, your gates, locks, all these things, security guards, CCTVs, right? If someone has managed to, but it's like just so that no one can enter your organization and then connect their devices, like how Mr. Robot connected it inside that, right? So that is their perimeter security. But say if someone is attacking from outside, then perimeter security won't be of much effect. They, what they'll face first, they'll face the network security part. So they what they'll face the firewall here, right? The firewall, your IDS, intrusion prevention systems, all these things you can say, okay, they are used for your network security. Okay, so if someone has managed to breach this, then what they will reach? They'll reach the devices out there. Okay, so for your device protection here, you know, you can make use of the anti-malwares, right? Your endpoint detection and response systems, EDR, extended detection and response systems, XDR, we can use over here, right? Then for your application security, you know, these applications can also have flaws in them, so you'll use the secure coding techniques over here. Okay, email security can also come under this, right? And then your data security, you need to encrypt your data properly. Right. In endpoint security, you're also talking about the user security, because users are the one who are using the devices, right? So you can see that security controls what we have spoken about over here. All these security controls, be it network and all these. So this is looking at your network part, emails is looking at your application part over here. This is looking at your apps, also users, also device, also right. Endpoint again, it is looking at your endpoints as already mentioned. Okay, user and data. So we there's all these security controls, they can be applied organization wide in using the defense and depth, like from this defense and depth model what we have. So everywhere in all these layers we can apply these AI based security controls, right? So now that we have seen, okay, we have seen the strengths of these systems, also we have seen opportunities where all we can use them, right? uh, what we'll see that how these AI models they are developed. Right. So for that, we have our entire AI model development life cycle over here. And initially, what you're doing, you need to, okay, you need to plan, right? What kind of model you're building, what security controls you're using it for, all these things you need to plan. Where will you get the data from? How can you get the data safely? How will the PIIs or your personally identifiable information, how will they not be compromised with? Okay, so all these things we need to plan here. Once we have planned, then we need to collect our data. Okay, so when you're obtaining your data, so initially you have your unstructured data. Okay, what all data we have seen, what all things can be collected over here? Say, if we stick to those AI based security controls only, say for network detection or for email or for malwares one, like what all we have seen, what all data can we collect here? So if you are building a model for phishing email detection, what all raw data do you need? Email, text data, or you can have the along with that you can have links also, links, right? So what all data we can say here? We have email data, we can have links, we can have files, malware files, right? Malware files, normal files, right? If we are building it for network anomaly detection, then we can have your captured packets, right? Packet data. This is your unstructured data. It's not organized into rows and columns. There is no fixed structure over here. But for training our model, what we need the proper structured data. Okay. So for this, we need to do the pre-processing phase, right? There will be the data pre-processing. So data pre-processing will even, so if you're using supervised learning, it will include labeling your data. Okay. It will include cleaning your data set, right? Filling the missing values, checking and filling missing values. Okay. And what, so once you have got this, so you can even normalize your data. Normalize means convert all your data points to between, say, 1 and -1, right? That way, much more computing power won't be required that way, right? Normalization means you're just compressing your data. So say, visually, your data set looked something like this. All the data points were all over. Let's say it is like between 5,000 and 10,000 over here. Right. So what we are doing, we are not changing the shape of our data. We are keeping the shape same only. Like this something, the data points will look similar only, but it will get compressed to between 1 and -1. Right. So that is normalization. So all these things also you need to do. That's why you'll see that different points are there. So then you will finally from unstructured data, you will get a structured data set. That is the data pre-processing part. Then you need to explore, validate your data. That is also called as your feature engineering step. Engineering or feature extraction. Okay. So now before feeding it to our algorithm, we need to tell our model what it actually looks like, what that data looks like. Means what all features you need to focus on while looking at the data set. So that's why we are transforming the data set even further, right? So overall you can say your model building part, you're converting, you're dividing them into your data engineering phase and your model engineering phase. Okay, so this thing I will just show it to you through an example code, that how you're doing these different phases of to build a machine learning model, what all phases you're going through. So this thing that you have here, see, though you'll feel that okay, so much code is written, but trust me, for developing this, you can even make use of AI tools. Right? There are many no code, low code, no code frameworks that are there. Right? And then you can make use of many GPTs that are there, right? Specific tools like yours. So I'll tell them about you. So these tools that are there, you can get this code generated, provided you know theoretically what all things are supposed to be done, right? What all prompts you'll give over there, right? You need to give the proper prompts for this. Okay. So you can see all this. So this is written in Python. Python is the best language for building any AI model that we have here. So as I mentioned, you have data, compute, and algorithms. So first of all, you can see my data set over here. One is my normal data set, and one is my data set that has DOS attacks in it. Okay, so step one here is I collected my data and I loaded my data set over here. Step two, you can say here, I'm not, so now I'm doing all the pre-processing tasks, right? So what I'm doing in pre-processing, I am labeling this data set. The normal traffic I've labeled as 0, DOS traffic I've labeled as 1, right? Then I'm combining this data set, okay? So these steps that you're seeing are all part of pre-processing. Then what I'm doing, I'm now doing the feature engineering part that you saw over here, feature engineering or feature extraction. So say if I'm building a model to detect DOS attacks, so can you tell me what are the features of that? How will you identify a DOS attacks? Example, if I'm creating a model to build DOS attacks, can you tell me the features of a DOS attack? How it will look like? How will you differentiate it between a normal attack? Okay, so these are your traffic. So PPS, I'll say packets per second, large traffic, right? There are many other things. If you're doing, say, some DOS attack over there, or some SYN flood attack, some flooding based attacks, so you will have some TCP flags over there, and they will have data associated with them, right? So that is also a sign of this. So you can see based on all these, see, the original data set I had looked something like this, right? These were the column names in our original data set. But from this data set, say if I want to take the time difference, so what I will do, I will subtract this particular value from this value. Okay, and that will give me the time difference for this particular packet over here. So that I will create a new column here, a new feature that will say time difference, and it will be nothing but the difference between these two values, right? And so on. For this value, it will be difference between these two, then difference between these two, and so on. Okay, so in this way, what I'm doing the feature extraction. I'm extracting the relevant features that I need. Okay, so you can see these all steps now. From step 4, you can see these are the feature extraction, calculate time difference, calculate packets per second, and what I'm doing, identify UDP and TCP packets is one of them thing. Then identify TCP flags with data. So all these things, new things that are created are the new columns, right? So what I'm doing with my existing data only, I'm transforming it so that my machine learning algorithm, what I'm using here, will identify these features only, right? It doesn't needs to look at anything else, right? Why waste the computer power looking at why waste the compute power looking at things that are not required? I will tell my AI, the algorithm, what things it needs to look at specifically, right? So I'm telling it, the pattern identification is happening. So now I will tell it what patterns it should focus on, and now within it, it will see that okay, what a 1 looks like, what a 0 looks like. That pattern recognition that AI will do on its own, right? Initially it just needs one push, right? That initial push is given by the feature engineering part. Okay, then I told you that in data preprocessing we have this normalization step only, where I'm converting all the data to stay between ones and minus one, right? Or say 0 and 1, or between minus 2 and 2 at most. Okay, then I'm saving the pre-processed data set. So finally I have my final data set which I can use with the model, right? So now this was our data engineering phase. Next phase, what you see here is the model engineering phase, where you will select and train the model. You will select that which machine learning model is best to use over here, or which deep learning model is best to use here. Then you will test your model that you have built. Okay, then what you'll do, you will evaluate, like you will check things like accuracy, right? How accurate it is, right? Other things are also there, like your confusion metrics, false positives, how many false positives it is giving. So if you're not happy with your model, you will have to fine tune it, right? Either by changing the data, or either by changing the parameters while we were training the model. Okay, in case we are fine with it, then we can deploy the model and monitor it, right? So continuous deployment, continuous monitoring, that is all part of your ML ops, right? And then finally, that because you need new data is also incoming, then you need to retrain your model. So this step here, that's why we're calling it a life cycle. This is just continuing again and again, right? So this model engineering part, when you see over here, you can say we are training. So for training the model, what we need to do, we need to split our data set into the labels. So I'm telling y variable will have labels inside them, and x variable here will have all the other features, right? All the other new columns that we have made. It all of them will stay here. Then we will split the data set into 80 percentage and 20 percentage. So 20%, 80% will be of our data set will be used to train the model, and 20% of the data set will be used to test it. Okay, so we are using both here, random forest algorithm and decision tree algorithm that is there. Right. So directly we don't, this code is very simple. You just have to mention this particular model name that you're using. Right. Again, mention the model name, and these are the parameters that we give here for training it. If we are not happy with it, if we are not happy with the accuracy, we can change these parameters over here, right? Different parameters that we have. Right. That's why a lot of trial and error is also required over here by changing these parameters when we are building these AI models. Okay, then finally we will because right now the model is in a variable. So what we'll do, we will create a new file of our model, right? So that we can integrate it with, say, the sim tools, right? These are the models that we've created. And then we will evaluate it, that we'll check the accuracy, the false positives, all these things we'll check, right? So you can see it is giving accuracy of 99.5%, this decision tree, and random forest is giving accuracy of 99.8. It is giving very good accuracy because I have already fine tuned the model over here, right? This is giving idea of false positives and true positives. This you can say the one false positive is here, one false negative is there, right? These are all the true positives and true negatives, 612 and 57. Okay, then finally what I will do, I have collected a new data set that is full of attacks, right? A DOS attack data set. So that particular data, like when I attacked that, so my snot, my IDS was not able to detect it. So I was trying out whether this model that I've created, whether that will be able to detect it or no. So while deploying it, you have to use the same code, right? Same code what you had used earlier, right? This is, and just not the training part, directly you can go for the testing part. So see, whenever your new data is incoming, your new data has to be pre-processed and has to be feature engineered, right? So that part will be the same. And then what you're doing, you can just predict over here whether it is DOS attack or no. So you can see decision tree model is not working that well, right? Though overall it is predicted it to be a DOS attack only, but you can see a random forest model is working very nicely over here. So these are multiple packets. So around like 2700 packets were there. So out of that 2200 packets, it was rightly detecting it as a DOS attack over here, right? So this way, like we went through our entire model development, AI model development life cycle over here, right? So you can see for insider threat, if we want to detect, so these are the data that we want to need, like the access patterns, these things we want to see, right? For endpoint risk forecasting, right? What we see, so these are all the things where we can use them for, that are device that are likely to be compromised next. Web application attacks, we can see it predicts that bot driven abuse, or your DOS attacks, your DDoS patterns also, right? Patch management, you can prioritize over here that which unpatched vulnerability are more exploitable over here. Okay, a phishing risk analysis, who is more likely to click on the phishing links, right? All these things we can do. And now finally coming to even the threats or problems with AI that are there, right? So what all things are there, these AI systems, they can show some bias over here. Okay, so for fairness, we need to ensure that our data is well represented. Okay, so say if you have see here, we are not just talking about social bias, like societal bias. You can have, okay, there has been documented cases where there is a image recognition tool, and it was not able to recognize the people of like certain race. They were not able to recognize them properly. Okay, and then there were cases where the job hiring tools, they were screening the uh, resumes of certain gender or certain like that way, right? So this is why, because the data there is pathetic, right? Garbage in, garbage out, that way that we call it, right? So we need to ensure. So see, it's not just about societal bias. If you take the case of network anomaly detectors, so if you're training your models to identify only a few attacks, so that way it won't work for other attacks, right? So even our data from a network point of view, from a cyber security point of view, it should be well represented, right? For that we have to ensure the fairness, right? So for that we have some tools like this what if tool, right? IBM Fairness 360, right? Microsoft has the Fair Learn tool, right? So all these frameworks we need to apply there while building the model. Okay, then what we have seen are AI systems, they are generally a black box. Okay, so we can make use of some explainability tools and explainability frameworks like this Lime and Shap. So what this is doing, this can even tell you that okay, this is the decision we have got, why we are getting this decision, this also these frameworks will tell us, right? So you have the explainability issues, you have fairness issues, and what you have, this robustness is issue. As I told you, AI models themselves are a new attack surface. Okay, so I'll show you one thing that I made an anomaly detector which we can use, which we can even use them with our IDSs over here. So what I did one adversarial attack on that. I gave it such inputs that reduced its accuracy. Okay. So what I'll do in the time being, I will you can fill the feedback form also. You will get the CP points while we are seeing this project. I'll just hand this feedback form to you, and in case you're getting late, you can just fill the feedback form. And so, okay, and like for these, for the contents, like these contents that are there, though you know that we are not allowed to share the slides, but some of the contents you will find there in my LinkedIn also. So you can follow me or connect with me on LinkedIn. I will give you my the link of my LinkedIn profile also. So what we did here, we made a IDS over here. So I would explain right now the entire code that is there. So because in this we are building a IDS, is a very large project where we are building a IDS, the anomaly detector we are building. But you can say, so first we built the anomaly detector over here. Then what we did, we performed a adversarial attack over here. Right here we did the adversarial attack, right? And then we saw the accuracy before the adversarial attack and after adversarial attack, right? And then what we did, we made the system more robust by providing the adversarial training, right? And then again we check the accuracy before adversarial attack and after adversarial attack, right? So keep this in mind. First of all, see what kind of thing, what, because this may be confusing. So what we are doing here, see, say you have an IDS. Right, so traditionally we know our IDS is rule based, but for better detection, we are making them so it is rule based also plus AI based, right? And for this AI based, what we are doing, we are using a anomaly detector over here, network anomaly detector, right? So this network anomaly detector was built using that same AI model development life cycle that I showed you, right? So that life cycle is applied over there, and we built the AI detector and we integrated it with this IDS. Right. So now see what all types of attacks can happen over here. What all are the attack surfaces? One is your traditional, your network based attack. Right. So this can be your DDoS attacks, DOS attacks, right? Web application attacks. It can be the password cracking attacks. Okay, so one will be your network attacks, and other thing that is happening since it is using AI detection over here. So what you can do, you can do a attack on AI, right? So it is actually called as adversarial inputs. These adversarial inputs are nothing attacks that target the AI model. Okay, so now what will happen if your AI system is not robust? So what the threat here is, if the probability of detecting this network based attack, right, say one thing that you have here, say first time this is not happening, okay, your adversarial inputs are not happening, this adversarial attack is not happening, just the normal network attack is happening, right? So our AI model, it is detected to train it, it is trained to detect it, right? So that's why the accuracy of our model, the detection accuracy, say initially it is 90%. So out of 10, every 9 attacks you can detect them. Okay, but what this adversarial input will do, it will reduce your detection accuracy. Right? Say it will make it 10%. So in every 10 attacks, it will be able to detect only one attack. So how we are doing this is because we have created such kind of inputs, the attacker has created such kind of inputs that can fool this AI model inside. Right, you must have seen like I'll tell you one example, a more relatable example of this adversarial inputs. It's like when that self-driving car, that Tesla's cars were there. So what it had, it was identified to, it was trained to identify a sign over here. Say it is a speed limit sign, or say it is a stop sign, right? Say it is stop sign. So what we have seen, if we add even so, see the stop sign there is an input for your AI model in your self-driving car. Okay, so what we have seen, if we add some tape over here, right? So what it does, instead of a stop sign, it will read it as go, right? Or it won't be able to identify that this is a stop sign. Okay, so this tape that we added here was an adversarial input, right? So similarly, for our AI models, other models for that are used as anomaly detector, we can add such kind of adversarial inputs or such kind of data we can add into this, that its detection accuracy will completely go down. Okay, and that thing you can visualize it over here, right? One thing, this is here, right? What we have done here, you can see our IDS accuracy before and after adversarial training. So what we had, it had a accuracy of 78% initially. Then when we did that attack over here, right, it went down to 6%. Right, this you can see here. Clean test accuracy before adversarial training 78.2%. Test adversarial test accuracy before adversarial training is only 5.9. So adversarial test accuracy means when our model is under an adversarial attack. Right, so the attackers can bypass these AI detectors by performing this adversarial attack. Right, so that's why it is very important to conduct this adversarial training. Okay, so you can see after adversarial training, our attack, this detection accuracy is not going down. Okay, and now you know that AI, what we can do, we can even do some attacks like the model inversion attacks, membership inference, right, with which we can get the PIIs or get the training data out. Right, that's why it is the data anonymization over there is very important. This security control also we need to apply of privacy. Okay, and then uh, they have the AI systems, they have unintended harm they may lead to, right? They may give out false information, they may hallucinate, right? You must have seen the LLMs are just providing false information because mostly these LLMs, they just have that people pleasing tendency. So because of that, they just give out any answer even if they don't know its answer, right? Which can be it can cause a harm also in that way, because wrong information, they say, is even more harmful than any incomplete info. Like if someone says I don't know something, is still better than when someone is just saying anything, trying to manipulate someone in that way by giving any false statements over there. Okay, so that's why we are not just building a model over here. We need to consider the security issues also and design our model accordingly, right? So we are not just going for AI model development, we are following this ML ops over here. We are considering all the security considerations over here, right? The safe deployment, safe development, so all these things. So what this adversarial training what I showed you, that was a example of safe development, right? Using frameworks like this what if tool, fairness 360, lime and sharp are the frameworks for secure development for ensuring fairness, explainability, right? So that's why with ML ops, you're combining all your CIA tried principles over there: confidentiality, integrity, availability, right? Trust, explainability, all these things, making the system more robust. Because what you can do, attackers can perform the data poisoning. So what they can do, if they have access to the data set, so imagine what they're doing. The label for normal is actually 0, right? Label for malicious is 1 in our data set. What if they perform label flipping? What if they change the 0 to 1 and 1 to 0? Right? So that way, what it will do, it will identify the malicious traffics as. So what they'll do, this part also they will keep it as 0 only. Normal, they'll keep it as 0. And malicious also 0. Right? So that way, when the attackers will do the attack, this will go undetected. Right? So we have to ensure that data poisoning doesn't happen. Evade data. This model evasion is the same thing that I just showed it to you. Right? By doing the adversarial inputs, we were reducing the accuracy. Right? Since the accuracy was being reduced, so we were able to bypass the model, the AI detection model. Right? So how to ensure extract means, say that we need to keep the API keys secure over there. Right? If the API keys are exposed, you can steal the model. You can even extract the data out of it by doing the membership inference and model inversion attacks, right? So that will you'll make them more robust, more resilient by performing the adversarial training what we just saw, right? You can use frameworks like lime and sharp for increasing the observability, right, and adding more security controls into your AI systems. Okay, so different steps which we had seen. So in different steps, what also see key focus, this we've already seen that key focus, what is there of those steps, but how you can, while data collection, how you should perform the data sanitization, access control mechanism should be there. While feature engineering, we should prevent that feature leakage, right? And in model training, so we just saw this adversarial training how to do, right? Fairness and bias detection also should be there. Right, deployment, you should secure your APIs. You should, while monitoring the incident response, like the alerting tools, there should be up to the mark over there, right? And while response and feedback, the humans in the loop should always be there. Systems should always be audited, and they will be auditable only if they are explainable and interpretable. Right. So these are some of the names of the tools what we discussed. Like for every step, whatever security tools you can use, right, they are mentioned over here. You can have a look at them. And yep, so this was all. So we have seen the strengths, also the weaknesses of the systems, how we can use these AI systems as the security controls, where what all opportunities are there, and not opportunities not just for using them but for you also, that where all you can use them in cybersecurity. And since there are threats for these systems, so you also have an opportunity for securing these systems. So AI security talks all about these things, that how you can securely develop and deploy these models over here. right? So you have the option to zoom your screen, Anmol. Just check it, and you go to where you see the slide. You will see either if you're on your laptop, you'll see, or computer, you'll see there's a plus sign over there, plus minus sign towards the end.